The guard clause in C# is used to simplify data validation in our applications. Instead of spreading validation throughout our methods, we put the validation up front. This ensures we know exactly what our data should look like coming in, and then we check for all possible issues. We can do the same thing for data going out as well. In this video, we're going to look at how to set up a set of guard clauses, as well as how to make our lives much easier using the Throw NuGet package. Now, if you don't know me, my name is Tim Corey, and it's my goal to make learning C# easier. I do this by providing videos here on YouTube multiple times per week. Plus, I have a weekly podcast. I also provide courses on C#, web development, and much more at IamTimCorey.com. The profits from those sales are what pays for the free content here on YouTube, so that everyone can have a great education in C#, not just those who can afford it. Now, if you want the source code for today's video, you can go to the link in the description to get that code. All right, let's go over to Visual Studio and get started. What we're going to do is we're going to build a little console application. Now, typically with a guard clause, it's not just about having a little application. You usually have a class library you're trying to work with, or you're working through an API or other things where you might not know the validity of the data coming in. So we're going to kind of simulate that without going into all the depth of that. So we're going to create a class library, a console application with a class library as well. So let's create a console app. We're going to call this guard clause demo and guard clause demo app. And .NET 6. And then once this is done, we'll also right-click on the solution and say Add New Project. And we're going to add a class library. This class library will be .NET 6 as well. So we'll call this our, let's call this helper library, or helper lib or something like that. And .NET 6 as well. Now we're going to delete class 1. We don't need that. We want to create our own. And I am going to right-click on a solution and say Add New Item. We're going to choose the .NET Editor Config. That used to be right in the right-click menu, and it is in the preview version of Visual Studio, but for some reason, in this version of Visual Studio, it's missing. And I'm not sure why, but you can just right-click and say Add New Item and add an editor config called .NET. It says Editor Config 1, but it will rename it when you add it. Now it's just Editor Config. So I think it's going to have some kind of bug in the current version of Visual Studio that's causing it to be missing, but you can add it yourself. Okay, so we're going to go to code styles and say instead of block scoped, we want file scoped for our namespaces. I prefer that. Okay, but it's up to you. If you don't want to have file scope, no problem. You don't have to, but that's what I prefer. Okay, so that's our basic setup. Now let's create a class in the helper library. So we're going to add a class, and let's call this helper methods. And of course, the first time it creates one, it ignores the editor config. Whoops, our editor config code styles. It's file scope. It ignores it for the first one, but after that, it should take care of it. So we just right click on here and say quick actions and refactoring. And help on the namespace. There we go. Convert to file scope namespace. And we can get rid of all the using statements as well and change this to public. All right. So this is our class. It's going to have some helper methods in it. This is just a way to demonstrate what guard clauses are. You would probably have these in a more complex environment, but the basics are when you have data coming in that you're not sure is totally valid. Now, one of the questions going to get asked is, well, but I validate my data up front. So maybe you have a user interface and you validate your data then. So why would you ever validate it again? And the reason why is because what's called defense in depth. If you validate your user interface data, that could be great, but are you using an API then behind your UI? Well, then you should validate at the API as well because the API can be called directly. Are you using a class library? Well, maybe a different user interface is calling that class library, not just yours. So there's a reason why we have defense in depth, and it's to protect our data. Data is very important to get right. If you get it wrong, you can cause some serious problems. So this is why we're going to have defense in depth. So public int age in decades. You're going to pass in an age. So what it's going to do is we're going to pass in an age. Let's just say 43. And then it's going to tell you, okay, you're 4 decades old. Okay, a decade is 10 years. And it's going to round down so that, if you're 9 years old, you're not yet a decade. So you're 0 decades old. Okay, so we want to basically just return age divided by 10. Since it's an integer, it's going to return an integer, which means it's going to truncate everything after the decimal point. So 11 divided by 10 is going to be 1. All right. Now that's best case scenario. But imagine we have, let's start calling this. Let's go to our guard clause demo, right click on dependencies, add a project reference that class library. And we'll say at the top, using helper library. And then we can say helper methods. And we'll call this helpers equals new. And we can say helpers dot age in decades. Let's say 43, pass that number in. And let's wrap this whole thing in a console write line. So that would be our result. Helper age in decades is 43. We could capture this into a variable. Let's do it for clarity's sake, I guess. So int decades equals that value, and then we can say 43 in decades is decades like that. So 43 is 4 decades old, is what we're expecting to see. Let's run this to make sure it does work. That's the first thing. Okay, 43 is 4 decades old. Cool. So we've got a working application with working helper method in a helper library. Great. But what happens if someone gives us information that maybe is unexpected? So let's copy this and put it down here and say, well, what if he put in a value? Well, first let's put a value of 49, just to make sure we are truncating our division. Okay, so 40, whoops, you have to change this value too. 49. So 49 is still 4 decades old. Okay, cool. But then what if we do it again, but this time we say negative 20. All right, so let's see what the value of negative 20 is in the number of decades. Negative 20 is negative 2 decades old. Well, I mean, I guess technically, but you can't be negative 20 years old. And that's an age. So that's an invalid number that's getting through because we're not doing any kind of guard clause guarding our method against working on bad data. Now, this is a simple example where it's not a big deal. However, it could be a big deal if, let's just say we wanted to get the number of decades of every person in our database, add them together to get the total number of decades of experience. So we have 10 people. We're trying to figure out how many decades of experience they have. And the first 9 add up to 20 decades of experience. Cool. But then the last one is, negative 200. So if we were to run this, you see how it says negative 20 decades old? Well, if you have 20 decades of experience and then negative 20 decades of experience, you add the two together, you get 0 decades of experience, which would be wrong. It'd be bad data. So that would be a problem for us because when we add it all together, it makes it look like we have no experience. When we really do. We just have bad data in there. So we want to protect against that bad data because that bad data can wreck our information that we base our decisions off of. So we got to figure out how to deal with this. Or what if we have this happen, where maybe we don't have a negative, maybe we have, well, let's just take the negative off. All right. And we run this again, and we see 200 is 20 decades old. Well, now, instead of being 20 decades for the first 19 people, and then you add this together, it's going to be 40 decades, which makes it look a whole lot bigger than it really is, because someone made a mistake and said 200 instead of 20 for their age. Well, that's a problem too. It's really outside the scope of what how old a person can be. So again, bad data that we're not protecting ourselves against. So let's create some protections. And this is where a guard clause comes in. So what the guard clause does, it says, let's guard your method from bad data. So we're going to say if age is less than 0, okay, so that's a problem, it's negative. Then we want to throw a new argument exception and say the age should not be less than 0. Let's unpin this so we can see the whole thing. We also can then say name of age. What that does is it passes in which variable is the offending variable. In case you have more than one parameter you're passing in, which is the parameter that's the problem. All right. And this name of says, hey, give us this name. Instead of you trying to type it out and it being a hard-coded thing, we can use name of, which is great. And this is the generally accepted practice for how to do a guard clause. We throw an exception here. Now you may say, well, Tim, shouldn't we just have some kind of like Boolean return saying that didn't work or something like that? No, this is what exceptions are for. This is the whole purpose, is that you have done something that is an exception to what we want. We don't want exceptions. We don't want problems in our data, because if we just say, well, it wasn't quite right, then that allows the whole application to continue as if business as usual. Well, that's not necessarily what we want, especially if we don't control the UI. So this is what exceptions are for. And so this is a valid time to throw an exception. Now, we've got this exception, but we need one more. So let's copy this and we'll paste it again. But this time we're going to say if it's greater than, let's say 130. I believe the oldest person in the world right now is 125, which is ancient. That's pretty awesome. But that means that there's no one that's over 130, and probably won't be. But we could say 140 or 150 if you really wanted to, but we're going to stick with 130. Because the other thing is, are the 130-year-old people going to be in our database? That's the other part of it. But the age should not be greater than 130. All right, so there's our exception for that. This is a guard clause. It's guarding our method data coming in to make sure that it's valid data. Now, the other thing this does is because it's all up front, instead of intermixing this in our method somewhere, since it's all up front, it's very clear when you look at this what the data should look like. It should be greater than or equal to 0. It should be less than 130. You're starting to see the boundaries of our data. This is kind of like having dependency injection, where you look at the constructor and go, okay, this class depends on these dependencies. It's right up front instead of mixed into your class somewhere. This guard clause is something similar, where we can look right at the front and say, okay, these are the parameters for our data. Now, if we run this, well, first of all, it's going to have an exception. Boom. Okay. So we have this exception and it stops our application from running, which isn't necessarily ideal. We want to do something with that exception. So we would take this right here. Let's cut it out. You could wrap it, but it's easier to cut sometimes. And we're going to put this inside a try catch, and we're going to say console write line ex.message instead if you have an error. All right, and we'll do the same thing here. I'll show you that other method. You can right click and say snippet surround with, and then just type try and tab, and it puts it inside the try. So there is a way to do that easier if you find that easier. And we'll do a console write line ex.message. They may say, well, Tim, why do you do 2 different try catches instead of just 1? Well, because I know that both of these are going to throw exceptions. I want to see the message for both of them. So if I wrapped both of them in 1 try catch, the first one would have an exception, the second one would never execute. So this way I can execute both of them and see their messages. Let's try it again. And this time they all run, but we can see that 43 is 4 decades old, 49 is 4 decades old, but the age should not be less than 0 for the age, and the age should not be greater than 130 for the age. So this tells us that we've successfully guarded our method from these issues. However, if we look back at this code, what used to be 1 line of code, which of course is obviously very simple, is now a lot more. And we're doing a lot more verbose stuff. So instead of doing this, having this verbosity, we can make this easier. And that's where we could create our own static methods that do guard clause stuff. And I've seen some of that. The benefits of doing that is you can create your own methods that do multiple guards inside of 1 clause. So you can say, hey, just check for an age. And it does all the age checks. But then you have the problem of, well, but it's an age, but it might be an age of a person who's been dead for 100 years. And we're trying to calculate their age as if they're still alive. Well, then your upper range would be you couldn't check your upper range. And so we'd have to take that clause out, which means a different check, and it gets a little messy. So typically I like to see individual checks instead of trying to group them together and save a few lines of code, because individual checks allow you to be more flexible in your checks and allow you to specifically ask for what you want. And you could write this all by hand. However, there is another option, and that is the Throw NuGet package. So let's go to our helper library, right-click on dependencies, and say Manage NuGet Packages. We're going to browse and say Throw. It's just called Throw. Okay, and currently it's in version 1.2.0, but whatever the latest version is, go ahead and install that. And this does work for .NET 6 and above. It's not a backward compatible to older versions of .NET. So now we have Throw installed, we can say using Throw. All right, we need to have that up at the top. We can comment out these lines. We're going to replace this functionality with what Throw does. So we're going to say age.throw if negative. That replaces this right here. We can do a second line that says age.throw if greater than 130. This replaces this. Now, I want you to see this in action before we can talk about how we can make this even easier. So let's run this. And we'll see it looks a little bit different, but it says the value should not be less than 0. That's similar. Parameter age, but that also has value, actual value was negative 200. It's a little bit of bonus information that we didn't have before. Notice it knows what the parameter is without me having to pass it in anywhere, because we just attached it right to the int as an extension. So we just said, hey, just, say throw on this if it's negative. Well, that knows what the parameter name is, and it grabbed it for us. Same thing with this. Value should not be greater than 130. Parameter is age, and the value was 200. So it knows the information, and it gives us that information in the exception. So that's pretty slick, all right? But we can make this even easier. So let's do that. So we can say, instead of having these two clauses, and I'll just comment them out so you can see them still, we can say age.throw, and I'm going to do this in separate lines just to make it easier to see. We're going to say dot if negative, and the next line dot if greater than, and we'll say not age, we're going to say 130. What this does basically is it just continues on a fluent pattern, so you can say, you can chain these together since they're all on the age parameter. So we're going to throw an exception if it's negative or if it's greater than 130. And you may say, well, Tim, what if it fails multiple clauses? Well, it fails at the first one. So if it's negative, then it's going to throw at that exception. And it's going to stop right there. But if it's not negative, it will look at this one and then determine if it should throw there. So if we run this, it's exactly the same as the previous version. So now, instead of having these multiple lines and the if statements and the long drawn out, specifying which exception and all the rest and the message, we just say age.throw if negative or greater than 130. Which also means that when you see this as your, at the start of your method, it's very clear what's going on. Now, I'm going to cut this out temporarily. I'll put it back so you can have it in the source code. But notice that when you come into this method, you're just saying, if it's negative or greater than 130, throw your exception. That's very clear what's going on, and it's very simple. You've simplified this guard clause down to one line of C# code that checks for the various parts, and it gives you all the information you need in that exception, and even more than what we were doing. So a very clear and nice way of doing guard clauses. Now, the cool thing is throw can do a whole lot more than guard clauses, and we'll see some of that coming up. So let's minimize this method, and we're going to create another method. Public string test name. We're going to say pass in a name, and I'm a little, proud of my name. I think that my name is great, and I'm going to create a method to rank your name based upon my name. Is that a little egotistical? Probably, but that's okay. It's a good test. So I want to say if name contains Tim, then I'm going to say return great first name. Okay. And I'm going to say if name contains Corey, I'm going to say great last name. And I'll return way to be unique if neither of those passes. Okay, so that's my normal method. But there's a few things that I don't want you to do. First of all, I don't want you to say you're Tim Corey, because you're not. I'm Tim Corey. That's the whole thing. I am Tim Corey. So if you say you're Tim Corey, I want to say no, that's not right. Okay, you can't use my name. I also want to check to make sure that you don't give me a blank name, maybe just spaces. Because I'd say, hey, way to be unique. Well, that's not what we're looking for. It's not a name. And what if I gave you just an empty string? Again, that's not unique. That's invalid data. So let's do a guard clause on this. Name dot throw. And then we're going to say dot if empty. Okay, so it's an empty string, and that's a problem. If white space. Okay, so if it's just white space, meaning just spaces, then that's a problem. And I'm also going to say, hey, I have a problem with you using my name. So I'm going to say dot throw again, which you may say, well, why are you doing dot throw again? Well, because this one up here, what it does is it says, hey, use the exception that makes the most sense. Use the text that makes the most sense for each of these methods. If empty, use the text that represents being empty. as opposed to white space. But I'm going to create a throw where I pass in my own custom message, where I'm going to say, sorry, you can't use my name. Something like that. That's the exception message. And when does that happen? If equals, I'm going to ignore case. So if equals Tim Corey. And I'm ignoring the case here, which means that if you say all lowercase Tim Corey or all uppercase Tim Corey, doesn't matter. I'm ignoring the case. I'm not going to say, no, if it equals Tim Corey, then sorry, you can't use my name. So let's try this out. We're going to save this. We're going back over here, and down below, we'll leave the stuff in. We're going to put a blank line in between our different checks. And down here, we still have our helpers. So we're going to say, let's just say console write line helpers dot test name of Tim Smith. Okay. And that should say great first name, because Smith is a different last name, but you got a great first name of Tim. And for this one, we're going to say Bob Corey. Well, you got a great last name there. So then we're going to say, well, what if we have something totally different? Sue Storm. Well, then that's a unique name. So we're going to congratulate Sue on a unique name. But let's do a couple tries here. And we're going to start with, let's put our exception. We're just going to, again, grab the console write line that says ex.message. And we're going to pass in helpers dot test name of Tim Corey, just to verify that, in fact, we can't say Tim Corey because that's a problem. All right. Next up, what we're going to do is we're going to try the same thing, but this time we're going to pass in an empty string. Okay, just nothing there, just a double set of quotes. Or what if we put something there, but it's just white spaces, just some spaces? What happens? So let's run this and see what happens. So great first name, great last name, way unique. Sorry, you can't use my name. The parameter is name. The string should not be empty, parameter name. The string should not be white space only for the parameter name. So these are our standard messages. This is our custom message for that exception. So that shows you how to set up that guard clause to make sure that you validate that the data is correct coming in. But we're not quite done yet, because what if we decide, you know what, I know that strings can be null, but I want to be, declarative up front that I want to allow null. Like maybe the data coming in could be null. Now, you may say, well, why would you allow a nullable string to come in if you know that it shouldn't be null? Well, what if this is attached to an API? You don't know for sure that string is not null unless you check for it. Now you notice right away we have this issue right here where we have this green squiggly because it's saying, hey, I can't throw on a null object. Well, we can say throw if null. And that's going to throw an exception if it's null, or if it's empty, or if it's white space. And then it will throw this message if it's Tim Corey. All right, so that's the only change we need to make, is throw if null is the first parameter instead of just throw. The rest of these can be exactly the same. Now, basically what it does is it figures out that, yeah, it's not null, so it can keep going to the rest of them. Now let's come over here and write one more exception, or one more test here, or try, where this time we're going to pass in null. All right, and we'll see what happens. So let's run this. And these up here run the same. And this last one, value cannot be null, is the new one. It still works. So the only thing that changed really is that we now have the check for null as well. So this is how you check if something is nullable, let's say an object, such as a class instance. That can be null. Well, you can do a null check first using the throw if null. And maybe that's all you do. But maybe you also check the values inside that class once you check to see if it's null. Because if it's not null, then you can continue on in the checks as if it's not null because you've already verified that it's not. So that's how we add a check for null. So there's a lot of things we can do here. And I'll tell you what, we're only scratching the surface. I did want to cover just guard clauses, and that's what we're doing here. By the way, you can cover guard clauses on the other end as well. Let's just say you're doing some type of math work in your method, and you don't want to return an index out of range or a value like infinity or negative infinity. Well, you could check for those things before you return the value and put a guard clause on the outside as well, on the return. So you have that right before the return value. That's what guard clauses can do. But I tell you what, this the throw, this right here can do a lot more than just guard clauses. In fact, if you go to their site, let me drag this over here. This is the documentation for the Throw NuGet package, which is great. Getting started, how to get started, turning this right here into this. And then it talks more about customizing it, how you can do things like if true and if absolute and if port and if HTTPS or not HTTPS. And if negative, positive, out of range, not equal, equal, and so on. There's lots of stuff you can do here, including conditionals for only throwing if you're in debug mode or only in release mode. So lots of stuff here, great documentation. And if you scroll down here, you'll see a lot of stuff in here. So for strings, here's all the stuff you can do with strings just out of the box. You can extend this even further. So I would encourage you, if you start using this, learn the tool, learn how it can make your life even better beyond just simple guard clauses. For instance, you can do, if you're passing in a string that should be a number, and you're going to do a conversion on that, you can do a throw based upon if the value is not convertible into that number. So stuff you can do there as well. You can do regex matches. So really cool stuff. You can check that if a collection has null elements, or if it's outside a certain range, or if it does contain or doesn't contain values. You can check date times, if an enum is out of range, if the date time is default or not default, check URIs, and so many more things you can do in here. And again, the documentation is excellent. So I do want to show us off. It's a third-party package that someone created that I think we should really support because it does a lot of the work for us. And that's one of the things that's very valuable here is it's doing work for us that we'd otherwise have to write ourselves. Now, yes, you could write it yourself and you could make things that are similar, but why reinvent the wheel? That's not your purpose, and it seems like a really good library to add that doesn't add a lot of scary problems as far as we can't upgrade everything else because of this dependency, because it doesn't do that. So you have a lot less to worry about there. It's not a big dependency to add. So something to think through. Definitely want to go check it out. I'll leave a link down in the description for the Throw NuGet package, but it makes our life a whole lot easier with guard clauses as compared to us writing the code ourselves. Okay, but either way, the guard clause is really important in C# to make sure that we have that defense in depth. We shouldn't just rely on, hey, the outer edge is protecting us all the way through, because it really can't. Okay, so this way we're gonna protect that defense in depth, just like a medieval castle did, to protect us in continuous layers instead of just a hard outer shell with a soft, gooey center. Okay, I would love to hear what your thoughts are, questions are, comments. ideas for what you'd like to see in the future, leave those down in the comments below. Or if you have a suggestion for a future video, go to suggestions.imtimcorey.com and leave that suggestion there, or upvote one that is already there. The videos that I do really do come primarily from the suggestion site. So the more interest I hear on something, the more likely it is that I will do a video on it, or a course on it, or a Dev Question podcast episode. Okay, so thanks for watching, and as always, I am Tim Corey.